going to run through a couple of examples of problems involving solving differential equations. These are the differential equations from the review packet that I gave out, so you can follow along with your review packet, or you could use this to check your review packet as well. Let's take a look at the first one. The first one is dy dx equals 4xy. Remember, the concept here is very simple. You've got x's and y's basically on the same side of an equation. You don't want to take an integral with x's and y's in the same part of the equation. So the idea is that you multiply and divide. You don't want to add and subtract, but you could multiply and divide to try to get all the y's on one side, all of the x's on the other side. You want the x's on the same side with the dx, you want the y's on the same side as the dy. So for example, I can multiply both sides here by dx, and that's going to cancel the dx on this side. It's going to leave me with just a dy on the left-hand side. Next, I've got a product here. I don't want the y to be on this side. It's part of a product, so I can divide both sides by y. Keep in mind, that's a 1 dy. So I'm really dividing 1 by y, and I'm getting 1 over y. And now, I've got just a 4x left over here, a 4x dx. Okay? At that point, I've separated variables. Now I've got two equal things. I can take the integrals of two equal things and get two new equal things. So I'll take the integrals of both sides. Remember, that's y to the negative 1 power. If I write that as y to the negative 1 power and I raise the power becomes 0, and then I have to divide by 0, which I can't do. So remember, that's the derivative of the natural log function, natural log of the absolute value of y. Technically, you can put a plus c in there. That plus c could then be moved to the other side. I'm just going to move both of my constants over to the same side at the same time. You can show that. AP exam doesn't usually require you to show it though. Over here, we're going to take the integral, raise the power by 1, divide by the new power. That's going to give me 2x squared. Somewhere you've got to have a constant. That constant needs to go in right now because when I make changes to solve for y later, that may affect that c variable. Okay, so I've got the natural log of the absolute value of y equals 2x squared plus c. Remember that this is a log base e. So there are a couple different ways you can handle that. You can write that as the log base e of y, and you can convert everything over to exponential form. Or if you prefer, you could just take e to the natural log of y power, and then of course you would have to raise e to that power as well. E to a natural log power, those two things are inverse functions, they offset each other. I just end up with the absolute value of y equaling e to the 2x squared plus c. Once I've done this, there are a couple things that you can change. Remember that when you're multiplying values with the same base, you add exponents. So in the same sense, if I want to break this up, I could rewrite this as e to the 2x squared times e to the c. I'm multiplying two values with the same base. That means you add the exponents, which is what gives you here. E to the c is 2.718 to the c power. That's a constant. And so a lot of times to simplify the equation and put this in a form that's closer to what you're used to working with, we'll say that we're going to let this e to the c equal some other variable. A lot of times we call it a c naught to represent the initial value. Also, there's an absolute value here. If I want to remove that, I have to keep in mind that I could have had a positive or a negative there. So I'm going to let positive or negative e to the c be represented as c naught, and I'm going to change that in the equation. So my new equation, that'll take care of the plus or minus, that'll take care of the plus c. I'm going to write that as c naught e to the 2x squared power equals y. If you're given an initial value, you may have to solve for that value at some point. It could be positive, it could be negative. That's really where the plus or minus is going to come into play. It's not so much that there are two answers, it's that it may be positive, it may be negative. Until you're given the actual point that your function passes through, you're not going to be able to determine that. So anyway, that's what's going on in problem number 1. Okay? Let's take a look at problem number 2. This one should be a little bit quicker. This function is dy dx equals 6 over y squared. Same thing, I can multiply both sides by dx. That gets the x off the side with the dy. Notice 6 is being divided by y squared. Okay, I want to get rid of that y squared, so this time I'm going to multiply both sides by y squared. That's going to knock out the y squared over here. That's going to give me a y squared on this side. It's going to give me a much easier equation to integrate. Notice, I left the 6 on the right-hand side. Okay, it just makes things more complicated in some of these problems if you put it on the other side. I would have had to divide both sides by 6, and I would have a 1/6 y squared over here. And it just, in this particular one, it's probably not going to make a huge deal, but in other cases, it can end up as part of an inside function. It can really complicate things. So I leave the constant here when I possibly can, whether or not it's an actual number or, for example, a k. Now I can take the integrals of both sides. This side with respect to y, this side with respect to x. Raise the power by 1, divide by the new power. So I can write that as y cubed over 3. I could add a c, but I'm going to take care of that on the other side here. That integral is just going to be 6x. Don't forget your plus c. If you forget that plus c, a lot of things are not going to work out very well. So anyway, you've got this. Now I want to solve for y here. Y is being divided by 3. I need to multiply by 3. This whole side, it needs to be multiplied by 3. So that's going to give you an 18x plus 3c. Even the constant's getting multiplied by that value. You could set some other constant equal to 3c, but the constant does need to be multiplied by 3. And that's y cubed. Okay, the opposite of cubing something would be to take the cube root of both sides. This is not going to give me a positive or negative. You can have negative cube roots or you can have positive cube roots. So I can either show a cube root of both sides or I can take both sides to the 1/3 power. Those are the same thing. I think I'm going to take the cube root of both sides. So cube root of y cubed is just going to leave me with y, and then I'll have a cube root over here, and I end up with an 18x plus 3c. Okay? If they give you a point and they want you to find the particular solution, you would need to go back and solve this, okay? And they could give you, various different things. Let's say that this contains the point 1, 5. I don't know where this is going, but this would be what's called the general solution where you haven't solved for c. If they ask you for a particular solution, they want the solution that contains the point that they give you. So for example, if it contained the point 1, 5, basically I have to substitute that into this equation here. So I have to get 5 by taking the cube root of 18 times 1, which is just 18, plus 3c. Okay, I could cube both sides. I get 125 is equal to 18 plus 3c. I can subtract 18 from both sides. Looks like that's 107 is equal to 3c. C would be equal to 107 over 3. And you would just substitute that back in for your c. Notice in this particular case, if I subbed in 107 over 3, the 3's are going to cancel, and I would just get y equals the cube root of 18x plus 107 would be my particular solution for this point. Okay, that may not be the same point on the review, but that's the basic idea. You fill in x and y, you solve for c. All right? Moving on to example number 3. Example number 3, notice I've got a 1 minus y here. I've got a constant of 2. I'm going to multiply both sides by dx, and so I'll get the dy by itself. I'll have a dx over here being multiplied by 2 times the quantity 1 minus y. I don't want to add y there. You've got distributive property coming into play. I don't want something plus dx or plus dy or minus dy or that sort of thing. Everything needs to be a product or the reverse of a product, a quotient. So this is being multiplied. Hang on a second. This is being multiplied by 1 minus y. So I'm going to divide both sides by 1 minus y. And remember, that's a 1 dy over there. So I'm going to divide both sides by 1 minus y. And what's going to end up happening here, the 1 minus y's, of course, are going to cancel. I'm going to be left with 1 over 1 minus y. I'm going to be left with a 2 dx over here, which is going to be really easy to integrate. And so now I can take the integrals of both sides. That's a reciprocal, okay? It's going to be a natural log. It's going to be a natural log of the inside function, 1 minus y. Be careful, your derivative of your inside function there is -1, so you are going to need to apply the chain rule. And so that's going to give you a negative natural log of 1 minus y. Technically, you need a -1 in here as part of your derivative of your inside function, so you have to balance it with the -1. On the other side here, that integral, of course, is just going to be 2x. Don't forget your c. Any case where you're going to have to find a particular solution, you're trying to find that c. If you forget about it, you just slap it on at the end, you're going to get an answer that doesn't make any sense. I would get rid of the negative. It's going to cause problems. I would multiply both sides by -1. It's going to give you -2x minus c. It's going to knock out the negative here. Again, you can think of this as a log base e and go from log form to exponential form. If you want to raise e to the natural log of 1 minus y power, and then you can raise e to the -2x minus c power, that's also legal because you've got two equal exponents, so you're going to have two equal results. E to a natural log power, those things cancel each other out. I get 1 minus the absolute value of y inside my absolute value. Over here I've got e to the -2x minus c. Again, this is the same thing as e to the -2x times e to the -c. Remember, e to the -c is technically the same thing as 1 over e to the c if you cared. But once again, that's a constant. That's what I really care about. So I'm going to let c naught equal e to the -c, and I'm going to replace that in the equation. So I'm going to write it as c naught times e to the -2x. Okay, I've got an absolute value over here. If I remove that, I have to account for the fact that it could have been positive or negative inside there, and I need a plus or minus out in front of my expression. Now I need to solve for y. Various ways you can do this. Actually, I don't need the plus or minus here, as long as I make the plus or minus part of that statement there. So again, when I actually solve for c naught, if they give me an initial point, I can decide if it needs to be positive or negative. Various things you can do here. I would probably add y to the right, and I would probably subtract this from the left, and that would give you 1 minus c naught e to the -2x is equal to y. And that's your general solution. Again, if they give you a point, if they give you an initial value, you can substitute values in here, and you can solve this equation, and you can figure out what c naught needs to be. But in this case, I'm going to stop there. Okay? Moving on. The fourth example here, the last, at least in this video, I give you dy dx is equal to 12x squared. Notice in this case there is no y on the right-hand side. So really I can just multiply both sides by dx. Technically you could just say, well, this is a regular equation, I'm just going to take the integral. Really what's happening when you take the integral though is you're multiplying both sides by dx. And so you have a y side. Technically you take the integral of that. Integral of dy is just y. Integral of 12x squared, raise the power by 1, divide by the new power. You're going to end up with 4x cubed, and make sure you add your c. Again, they may give you an x and a y point that the function has to pass through. In that case, you would solve for c. But that's how separation of variables works. A couple different examples showing you some of the different things that you could possibly see. Hopefully that's been helpful.